So lately I've been thinking quite a lot that when we will get to see the 10 nanometer fabricated product from the Intel. Why? Because Intel originally did announce back in 2015 that they will release the 10 nanometer fabricated product in the mass production. But it is 2018 now and we are yet to see the product in the flesh. So in today's video, we will try to emphasize the various reasons why Intel is struggling with the 10 nanometer fabrication. So let's get this started. Alright, so without a question, Intel is one of the major player among the semiconductor wafer company. But unlike the Samsung or TSMC, it does not produce its wafer for the fabless companies such as the Qualcomm or Nvidia. And that's where Intel gets flexibility regarding the advancement of their architectural circuitry as well as the fabrication node shrink. And that's what Intel did for many years with their tick-tock model. Basically, what this means is every tick represents the new fabrication node and every tock represents the new architecture. But that traditional tick-tock cycle got disturbed after the introduction of Broadwell architecture back in 2014. And Intel has to change their strategy because they couldn't progress beyond the 14 nanometer fabrication. While in meantime, TSMC and Samsung progressed their fabrications beyond the 14 nanometer. So why Intel is handicapped at the 14 nanometer fabrication while its competitors are heading towards the 12 and 10 nanometer fabrication? Sure thing, Intel is shipping few of the products in the 10 nanometer fabrication, but they are in the low volume as well as it's not clear to what manufacturer they are shipping the 10 nanometer products. One of the major reason Intel is lagging behind its competitors regarding the 10 nanometer lithography is the absence of EUV in their manufacturing line. The EUV stands for extreme ultraviolet lithography, and Intel is not using the EUV equipments because of their higher costs. See, up to the 14 nanometer, Intel haven't used EUV technique in their manufacturing. But as the fabrication node gets shrink, the lithography techniques get more complicated and it needs to be more precision. And therefore, Intel must have to use the EUV technique in their 10 nanometer fabrication node. Some of the industry experts have also suggested that Intel haven't invested as much as its competitor regarding the equipments of the EUV. Why? Just for the sake of the cost cutting measures. But I guess it will hurt them more in the longer run when market gets more matured for the 10 nanometer fabrication products. And I guess it's going to happen soon. How about the intentional delay? Sounds totally strange, right? But yeah, it is totally possible. Look at this way. The advanced company like Intel, which has years and years of experience in the semiconductor industry, couldn't able to produce 10 nanometer fabrication product? Sounds illogical, right? See, it might like Intel is intentionally holding back 10 nanometer product. Why? Because they might not able to get the desired level of yields. It's like they might be able to get 85% of yield, but they are looking for the 90%. Just on the 14 nanometer, Intel have achieved 70% IPC gain from the Broadwell to Coffee Lake. So it's might like that Intel is looking for the best possible scenario on the 10 nanometer fabrication as well, just like the 14 nanometer fabrication. That's why Intel might be waiting for the exact moment, exact right time when their foundries might able to produce the desired level of yield in the mass volume. And finally, Intel's superior performance on the current 14 nanometer fabrication node might making them think that they don't need another die shrink at this point. How? For example, AMD's Ryzen processors are based upon the 12 nanometer and Intel's Coffee Lake processors are based upon the 14 nanometer. Yet Intel is class leading regarding the IPC single-threaded workload as well as most of multi-threaded workloads. So what this kind of performance exhibits? So this kind of performance exhibition suggests that Intel's current 14 nanometer fabrication node can compete or surpass its opponents 12 nanometer fabrication nodes. So therefore Intel might be thinking that they don't need another die shrink at this point because its 14 nanometer node can compete with its competitors 12 nanometer node. So therefore they might be staying on the 14 nanometer fabrication node at this point, but they might be working upon the 10 nanometer fabrication node for the future. And of course the 10 nanometer fabrication node or the die shrinking is the future. And therefore we are positive about Intel's 10 nanometer fabrication node. So hopefully they will resolve their 10 nanometer fabrication node mess in the 2019, and hopefully we will get to see some concrete mainstream product CPU in the 2019 from the Intel. So with that being said, let us know guys what you think about Intel's next strategy for the 10 nanometer fabrication, Will they able to do it into 2019, or we will get to see the another delay? Let us know via the comment section, and as always, subscribe to this channel if you haven't already, and I will see you guys in the next video. Till then, bye bye.